Hello and welcome aboard. We're going to be flying an NDB approach today. It'll be the NDB approach into Shannon Airport. So first we want to make sure that we've got our ADF set to the frequency listed on the approach 237. So that's in. And where we are, we're on the runway at an airport just about 5 miles to the north of Shannon. So it's conveniently set up for us to take off from here, get set up for the approach by just flying down towards the beacon and then actually performing the approach. Once we're airborne, we'll set up our autopilot. We'll be at 2,500 feet initially just to fly inbound, so we'll set up our climb there. Once we're climbing, we'll use the ADF to figure out our first heading. So that needle's pointed behind us and to the left. So we're going to set the autopilot to actually turn the aircraft in that direction where the arrow is pointing. The arrow is just pointing towards the station, so as long as we point our nose in that direction, we'll be also oriented that way. So we'll make a left turn, and as we're making that turn, you notice the arrow is starting to swing towards the front. So we can make some adjustments here just to keep that arrow coming towards the front. And now what we want to do is we want to match up our heading with what's actually selected on the ADF. So we'll turn and twist in that order so that they always kind of correspond to each other. So here we are on about a 180 heading, and we have 180 on the ADF, and notice that that arrow is pointed pretty much straight ahead. So this heading will keep us pointed in the direction of the station. And what we'll try to do is keep that arrow pointed straight ahead and also keep it frozen so that we know that we're not tracking to the left or to the right as we get closer and closer. So that's what we'll do here. As we approach the station from the north, we're just trying to keep that arrow pointed straight ahead. This is called homing to the station, and it's sort of the most basic use of the ADF. So here we are leveling off at call it our initial cruise altitude at 2,500 feet. This is where we'll be when we first overfly the field and start that turn to intercept the outbound course. And for now, we're just managing that heading to keep that arrow pointed straight ahead. If the wind was blowing us significantly left or right, we might not want the arrow straight ahead. We would be more interested in keeping the arrow frozen. In other words, we're not getting pushed left or right of our track. But for now, just to keep it simple, we'll keep that arrow pointed straight ahead. And it actually looks like, because it's not moving, that the wind isn't having too much of an effect. The wind is out of the north here, consequently, so that sort of makes sense that we're not getting drifted to the left or to the right. It's sort of a direct tailwind here. As we start getting closer, we'll notice that that needle gets more and more sensitive, and it's tougher to keep it frozen. We'll have to make smaller and smaller corrections until finally, notice the needle flips. So we've completely crossed over the station, and we can start our turn now to intercept. So we're going to make a left turn to a heading of about 012 degrees. It's a really good intercept. So we'll make that turn, and then we'll also set 12 degrees 012 on the ADF, so that turn twist that we're always corresponding. Meanwhile, we can descend down to 1,900 feet, so we'll have the autopilot do that for us too as we get set up to intercept the outbound course. So that 12 degree heading is a nice intercept to the outbound course. The outbound course is 57 degrees, so doing the math, it's about a 45 degree intercept. So as we roll out around about that 012 heading, and we'll make some fine-tune adjustments to make sure that we're on that heading, take a look at that butt end of the arrow on the ADF. And be watching for when that butt end of that arrow, the tail of the arrow, gets close to the outbound course of 057 degrees. Meanwhile, just making fine adjustments here, cheating a little bit using the simulator to see exactly what our heading is on the directional gyro. We're looking to maintain that 12 degree heading as close as we can. And again, that's what we have set on the ADF. So you're about 9-10 degrees. Maybe we'll make a little bit of a small correction to the right just to adjust and get as close to 12 as we can. Meanwhile, here comes the tail, getting closer and closer to that 057. So what we'll do is we'll now start a right turn as we're intercepting that outbound course. So we'll turn to 057, and we'll also set 057 into the ADF. making adjustments just to make sure we're on that correct heading. Continuing to pull that a little bit to the right to get that 057 heading in. And if we did everything properly, what we're hoping for is to see that tail end of the arrow, the butt of the arrow, on that 057 on the ADF. Now we got the ADF set correctly. And if we haven't quite gotten it, that's okay. We can make adjustments. So the rule of thumb here is push the head, pull the tail. So we're focusing the tail here, so we want to pull that tail. So right now the tail is a little bit to the left of where we want it to be. We want it to be on 057. So if it's to the left, we want to pull it to the right. So we've set our heading bug just to the right of that 057. So it's sort of like a 63, 64 degree heading here. So this is how we're going to pull the tail over to that 057. And if we hold that, as we notice, the butt end of that tail starts getting close to 057. So we can adjust back now, making a little bit of a left turn back towards that 057, and hopefully now we're tracking right on that outbound course. Notice each time we make a turn, we're also corresponding that turn to the ADF. So if we turn to 057, we have 057 on the ADF. That's the key to doing these NDB approaches, always making sure that the heading that you're flying to and the ADF are corresponding. And it looks like we're pretty happy here. We've got the butt end of that arrow on 057. We can make some small corrections. Again, it's pull the tail, so if the needle is a little bit to the right, we'll fly a little bit to the left of that. But for the most part, it looks like we're tracking nicely here. And we'll hold that. Small corrections here. And once we're happy with our outbound course, we can start our procedure turn to our heading of 103 degrees, right there on the barb. And we're going to get our clock ready too, because once we're on this 103 heading, we're going to start counting 1 minute out. Now you can set 103 on the ADF just to keep consistent, that corresponding the turn and the twist. Since we're not tracking anything, we won't do that, but we will definitely start our minute here to count our outbound. So, or to count our first procedure turn. So we're in a minute on this 103 heading. Once that minute is up, we're going to make a left turn 180 degrees around to a 282 degree heading. And that's going to be our course to intercept the inbound. So we're 103 now. After a minute, we'll be turning left to 282, and we'll hold that heading until we intercept the inbound course. There's 30 seconds, so we're just tracking. Again, we're not tracking anything on the ADF. We're just holding this 103 degree heading. So coming up on a minute here, we'll start that left turn around at 282 degrees. And now we do want to twist the ADF because we've made that turn to 282 and we want to know when we're on the inbound course. We'll also put 282 into the ADF so that they've corresponded. And as we come around to that heading, what we're going to be looking for, instead of the tail, we were concerned with the tail when we were on the outbound, but now we're looking for the inbound course. So we're looking at the head of that needle on the ADF. And what we're looking for specifically is once the arrow starts pointing close to our inbound course of 237 degrees. So again, making fine adjustments, we want to be on that 282 heading to track inbound. In theory, it's going to take us about a minute to get to the inbound course since we did a minute of outbound. but we're going to use the ADF to know for sure. So the head of the needle's in about 250. So we're going to keep an eye on that, and what we're looking for is for it to swing left, and once it starts getting close to 237, that's when we're going to make our left turn to track inbound. Just making fine adjustments here, make sure we're actually on that 282 heading. Notice the needle slowly moving its way. It was at 250 first, now it's sort of moving left through 245, and we're watching until it gets close to 237. That's how we know we're close to intercepting the inbound course. So here comes the needle through 237, so we'll make a left turn. We're going to come to about 240 on the heading, just for a little bit of a wind correction since the wind is coming out of the north, blowing us from the right. So we'll do that. And now that we're on the inbound course, we can also start our descent for the approach. So we're on the inbound course. We're going to tell the autopilot to bring us down to 1,100 feet, and we can also start to configure for the approach here. Nice 400 foot per minute, 3-degree glide path roughly in the Cessna. Bringing the power back to 1,700. And the flaps will come in too. And so now our main job is tracking inbound. We want the head of that needle to be about 237 degrees. We'll make corrections. Now again, it's push the head, pull the tail. So this time with push the head, if the needle or the head is to the left side, we're going to be correcting to the left side as well. So there's the head of that needle right where we want it at 237. That's great. It means we're on the inbound course, but it doesn't necessarily mean we're tracking. So if we notice that needle starting to swing one way or the other, we're going to want to correct for that too. Always just making sure that our heading and our ADF are matched up. Yep, 247 and 247, just making sure that we're matched here. There's our altitude. We're coming close to 1,100 feet, so we'll have a look outside. Lo and behold, there's the beacon, there's the runway, and from here we can start to make our descent and approach down to the runway for landing. So there it is, the NDB approach into Shannon Airport. As you can see, it's not an exact science, it's obviously a non-precision approach, which is why you'll see the minimums being a little higher, certainly than you'd see on like an ILS or something like that. It's just designed to get you close, so hopefully the weather is at least good enough for you to make an approach and a descent to land from there. But there it is, the NDB approach. So yeah, if you don't have an ADF in your plane and you can't find a working NDB approach at an airport near you, jump in a flight simulator, and you do the one here at Shannon, or there's still a bunch of other ones, especially out in Alaska or up in Maine, or certainly in Canada, where they're using NDB approaches. They're not the easiest, and we don't really have a chance to use them too often in practice, but I think they're good for you. I think that's good for situational awareness, just to get a sense of what the wind is doing to you, get a sense of intercepts and inbound and outbound courses, procedure turn. It's a good break from just following the line on a GPS, frankly, every once in a while. So go practice your approaches. Thanks a lot, everybody.